Hello students, good evening and welcome to APJ Academy. Dear students, can you hear me? Is I am visible to you and audible? Please let me know in the comment box if I am visible and audible to you. Right? Okay. So as you have seen from the thumbnail that today we are going to discuss about one of the most interesting chapter or the most interesting topic from chemical equilibrium, that is Le Chatelier principle. And you know that for NEET this Le Chatelier principle is a very important topic. Okay, you can see in the previous year questions the question regarding Le Chatelier principle, how the direction of the reaction shifts as you changes the variables like concentration, temperature, pressure, etc. Okay, so Vashu, hi, hello, how are you? So how's your preparation for the next year's NEET going on? So dear students, before getting into the chapter or the topic, let's get to know what APJ Academy is. Okay, so I'm going to give you a brief intro regarding our academy. So this is all about the full year course that we provide. Okay, and you can just see in the bottom of the slide that what all we provide. Actually we provide the PDF materials, so all the complete modules of physics, chemistry and biology, and along with the question bank. And we also provide the 25 major test series. And you know that understanding the concept is not enough if you are appearing for a competitive exam. Along with understanding the concept, you also have a grip over the numericals. You also have to work out problems. You also have to expose yourself to major, or you can say the difficult level problems, so that you have to repeatedly do more and more problems, so that you will get a good hand-on experience on certain problems, so that it will help you to improve your marks on NEET exams. Okay, next is the query solving. So query solving, you know that, see, most of the students get a problem regards to the concepts. Actually they may think that they have a conceptual clarity regarding a particular concept or theory or whatever it may be, but actually what happens is that once they start thinking on it, the doubts arises. So the doubts arises only because they have lack of conceptual clarity, and that indicates that the student did not understand the concept properly. So there should be a platform where you can ask your doubts and it should be clarified. Once your doubts are clarified, your concepts will be like a crystal clear water that you can see the reflection of yourself, right? So query solving is very important, and we test that with the teacher each 2 days. Okay, each 2 days you have a query solving. Now we have 20 lectures, up to 20 lectures, that is theory explanation in every month, and assignments also. You have after every lesson you have assignments, like you have DPPs, and because we know that just teaching you the concept will not give you the marks. You also have a good numerical skill, you also have a good problem solving skill, you also should have accuracy, you also should have efficiency, and you also should have speed in calculations or in solving problems. So all these skills can be developed if you do more and more assignments, more and more DPPs, more and more attending more and more test series, and these are the things which is going to help you to push your rank towards the top 10. Okay, so these all things are very important. So this is what we provide, and you will be amazed to know the price of all these things. We are just providing this course for just rupees 490 per month, and you know that that's an enormous discount that you're getting, because you will never see any course on NEET or JEE with this much amount only. See, you can calculate it, just take it as 500 into 12 months. You can see that it is around 6,000 rupees, right? It's a very low cost, but the thing is, whether it's low cost or high cost, the matter of fact is you have to study well. You have to listen to the class, you have to follow your mentor, you have to study well so that you can score good marks. Okay, end of the day your result matters, right? Okay, now if you are new to this channel, you can subscribe to this channel, because I am guaranteeing you will be getting a very good quality content on this channel, and that is for free, because we are regularly providing free classes on major and important topics that can be asked for your exam. Okay, so once you understand, once you listen to the class, in each class we will be doing certain problems also, numerical, analytical problems, numerical problems, theoretical questions will be done, and that too will be in the pattern of the NEET. Okay, so once you listen to the class and once you start doing those problems along with me, what happens is that you will become a master in that particular topic. That's what you have to do. We know that for NEET exam there is 98 chapters from physics, chemistry and biology all together. From 98 chapters we can take it like 196 or nearly 200 or 250 important topics from each subject. Okay, from total subjects. So we are picking those important subjects and we are going to give you those important portions where you have to focus on. Okay, so it is going to give you a very good effect, or it will help you a lot in your NEET preparations. So if you are new to this channel, please go and subscribe this channel. Right, now that's all about me. Now we are going into the topic. Right, so let's get started. So the very first topic that we are going to discuss today is all about the homogeneous and heterogeneous equilibrium. See students, you know that what is meant by equilibrium. We know that if a reactants combine together or they collide together, what happen? We know that if the collision is effective, then they produces products. Okay, that collision, because of that effective collision, products will be formed. If the formed products is unstable with respect to reactants, what happens? The products collide themselves and start to react in the backward direction. So we know that there will be a forward direction and there will be a backward direction. Such reactions are called as a reversible reactions. Reversible reactions are those reactions where there is forward direction reaction and there is a backward movement for the reaction. That means reactants react together to give products and products react together to give reactants. So in both the directions the reaction is proceeding. Such reactions are called as what? Such reactions are called as reversible reactions. So if the reversible reactions reach to a state where the rate of forward reaction, that is, what do you mean by rate? Rate means the speed of the forward reaction, and the rate of backward reaction, that is the speed of backward reaction, becomes equal, then that particular reaction is called as this reaction has attained a state called equilibrium. Okay, that means the forward reaction and the backward reaction, if their speeds are equal, then the reaction is said to be in equilibrium. So this is what I want to discuss about equilibrium. And we know that there are two types of equilibrium based on the state of reactants and the products. Based on the state of reactants and products. Okay, state means physical state. Like I have told you, we have two types of equilibrium. One is homogeneous. See, in homogeneous equilibrium you can see that all the reactants and the products will be in same phase or in same state, physical state. See, for example, you can see here, you can see that this is a Haber's process reaction where this reaction is in equilibrium. So you can see that nitrogen gas is reacting with or colliding with hydrogen gas and it produces ammonia gas, and ammonia molecules collide together and they are forming nitrogen and hydrogen. So these reactions are now reversible in nature, and it has attained, every reversible reaction will go and reach to a stable point where we call it as equilibrium. So it reaches to equilibrium, and at equilibrium you can see that nitrogen is in gaseous state, hydrogen is in gaseous state, and ammonia is in gaseous state. So all the reactant and product are in gaseous state. That means the reactant and product are in same phase. So the equilibrium is called as the homogeneous equilibrium. So you can see that this is all about homogeneous equilibrium. Okay, so hope this is clear. If the reactants and products are in the same phase, then the reaction is homogeneous or the equilibrium is homogeneous. So just you can just give off what is Kc, Kp, and Kc and Kp, the relationship between them, how to write Kc and how to write Kp, all these things we have discussed in the previous lesson. If you haven't watched that lesson, please go and watch it soon after this lesson ends. Okay, now coming to the next part, coming to the next example, here also you can see that I have given you an acetate along with water. Here you can see aqueous. Aqueous means in water or in liquid state. Here water also in liquid state. Here we got acetic acid as product, it is in aqueous state, that means in liquid state, and C2H5OH also in aqueous state. So all the reactants and product are present in aqueous or in liquid state. That means this is also another example for homogeneous equilibrium, right? Now moving on to the next one, that is heterogeneous equilibrium. So once you understand what is homogeneous equilibrium, then it is easy for you to explain what is heterogeneous equilibrium. So if the reactants and products are in same phase, then obviously that reaction or that equilibrium is called as the homogeneous equilibrium. And if any of the reactant or any of the product is not in the same phase, then that equilibrium is called as the heterogeneous equilibrium. That's what you have to understand. So heterogeneous equilibrium having more than one phase. Having more than one phase, you can I can give you an example over here. You can see that calcium carbonate is solid here, calcium oxide is solid here, but you can see that carbon dioxide is in gaseous state. So in this is another equilibrium where you can see there are two different phases among the reagents. Okay, the reactant and product together, we call it as reagents. If I use the term reagent, that means not only reactant, it is also meant as product also. So you can see that in an equilibrium, if the reagents having different phase or physical state, then that particular equilibrium is called as heterogeneous equilibrium. I hope this is clear for you, right? So you know how to write the Kc and Kp. Here interesting fact is that in Kc there is only one concentration term, and for Kp there is only one partial pressure term. Why that? Because we know that for every solid reactant and product, the concentration is taken as 1, and for pure liquid solution or pure liquid reactant or product, we take the concentration and or pressure as 1. Because for pure liquid means in chemistry we use the term pure. It's not the pure that you understand. It only means that it is not a combination of more compounds. See, if I tell you the aqueous solution of ethanol, so it is not pure. It is a mixture of ethanol and water. Aqueous means it is aqua. The term aqua means it's something that is mixed with water. So aqueous, we use the term aqua means it's water. So aqueous ethanol means ethanol mixed with water. So it's a mixture, it's not pure. Mixture and pure. Pure means that alone, that particular component alone. If I say ethanol liquid, that means ethanol alone. Okay, there is no mixing with water. So ethanol liquid is a pure component, but aqueous ethanol is not pure, it is a mixture. So we use the term pure in chemistry when that particular compound only exists in that particular state. We call it as pure. Hope that is clear for you, right? So this case, in this chemical equilibrium, you can see that the reactant is in solid state, the product is in solid state. So for solid state, the concentration or pressure is taken as 1. So you only have to consider the gaseous product or reactant while writing the equilibrium constant equation. Hope that is clear for you. Now, here you can see another example. Here nickel is in solid state, but carbon monoxide is in gaseous state. Nickel tetracarbonyl is in gaseous state. That means this equilibrium reaction is also heterogeneous since it contains one compound or one reactant that is in different phase or different state. So how you are going to write the Kc and Kp? You only have to write Kc and Kp. In Kc and Kp terms, you only will have this product and this reactant. This this need not to be written in your Kc or Kp equations, since it is solid. The partial pressure of solid is taken as 1, the concentration of solid is taken as 1, so need not have to write that. So this is the Kc for this particular equilibrium and Kp for this particular equilibrium, that is concentration of nickel tetracarbonyl and carbon monoxide raised to 4, right? Similarly, the partial pressure of nickel tetracarbonyl and the partial pressure of carbon monoxide raised to 4. Now the another equation and another reaction which gives you the heterogeneous equilibrium, that is Ag2O, that is solid, HNO3 is in aqueous medium, AgNO3 aqueous medium, H2O liquid, and you can see that these three are in liquid states, but this particular reactant is in solid state. So obviously this reaction or this chemical equilibrium is heterogeneous in nature. Hope that is clear for you. So if you are writing the Kc, this is a very interesting example. If you are writing the Kc, you can see that here it is liquid. So for pure liquid, you need not have to write the concentration. The concentration will be 1 for pure liquid and solid. So the solid also, the concentration is 1. For pure liquid also, concentration is 1. But these two aqueous mediums means they are a mixture. So you have to write their concentration terms in the equation of Kc as well as Kp. Hope that is clear for you. So that's it. Now we are moving to the next topic or the next question. Here you can see that this is a question that is asked in 2000, and you can see the equilibrium constant Kp for the following reaction MgCO3 solid giving MgO plus CO2 gas is. So you are asked to find out the equation for Kp. You know that Kp is equal to partial pressure of CO2 into partial pressure of MgO divided by partial pressure of MgCO3. And we know that if the reactant or solid or the product is in solid state, their partial pressure or their concentration should be taken as 1. So I can write it as 1. So the Kp will be equal to partial pressure of CO2. That means our option 1A is the right answer. Is that clear for you? Yes? Students, please let me know in the comment section if you are understanding what I am telling, so that it will help me to understand whether it is clear for you or not. If you need any clarification, please let me know in the comment box, so that I can explain to you, as I like explaining things more and more, so that it will get clear to you. Okay, my intention is that if you are listening to this class, I wanted everybody who listen to this class have to get a clear picture on this particular topic which I am going to discuss, or which I am discussing right now. Okay, so I need your responses, so that if you respond, that will make the class more interesting and it will make your studies more effective, right? Okay, now let's move on to the next topic, and that is regarding the predicting the direction of the reaction. So here students, here I want to introduce to you a new term that is called as reaction quotient. First of all, what is reaction quotient? So reaction quotient is a quantity, or it's a magnitude that help us, it's a magnitude or a quantity that help us to measure the rate of reversible reaction. It is not equilibrium, but I am telling it is a reversible reaction. So what is QC? The equation is similar. You can see that the equation for QC is equal to the equation of KC. So what is the difference between QC and KC? See, dear students, बैकग्राउंड का रिएक्शन नहीं दिख रहा पहले वाले का. ओके, सो पहले वाले का दिस वन, और ओके पहले वाले. ओके फाइन. सो आई होप द कंसेप्ट इज क्लियर फॉर यू. I'll check it in the next time and make it in the clear proportion so that you can see it properly. So please bear with me for now. Let's move on with the class. Okay, hope the upcoming slides will be okay for you, right? Now, and now we are going to discuss about what is QC and KC. See, every reversible reaction, please open your ears and hear this. Every reversible reaction will finally end to the point where that reaction becomes in equilibrium. Okay, initially, or I can say that every reversible reaction tries to approach equilibrium, or they always tries to reach to equilibrium. So for a reversible reaction, initially they are not in equilibrium. So at the initial point, if you want to analyze the rate of the reaction, or if you want to analyze how the reaction is proceeding, whether the products are formed more or the reactance is more, so understanding their ratio will give you a clear picture in which direction the speed is more or in which direction the speed is less. So to understand that particular ratio of the rate, we use the term QC or reaction quotient. So if this reversible reaction reaches to a point where we call it as equilibrium, then the reaction quotient at equilibrium is replaced by Kc. So what does that mean? That only means Qc and Kc is equal at equilibrium. You are only changing the alphabet Q with K. You are just replacing the alphabet Q with K when a reversible reaction reaches to the point called as equilibrium. And QC is not constant. QC keeps on changing. QC changes with time. Why? Because QC is just indicating the rate or the ratio of the reaction rate which is not in equilibrium. So if the reaction is not in equilibrium, the QC keeps on changing. So once the reaction reaches to equilibrium, we know that that reaction has come to an equilibrium at a point called as equilibrium. That means the rate of forward and rate of backward is equal. That means now QC is constant. Now you cannot change QC. Now no change will happen to QC. So if QC becomes constant, QC can only become constant when the reaction reaches to equilibrium. So we replace that QC with the term Kc. Hope this concept is clear for you. So QC, reaction quotient, we explain it for reversible reaction, and Kc, equilibrium constant, we explain it for a reaction that reaches to equilibrium. Okay. Now I want to give you a simple trick where you can solve any problem that comes with regards to explain the direction of a reaction giving the values of QC and Kc. Okay, so this is how we are going to do. I'm just drawing a line. Okay, so I'm just drawing a line, and here in the center point I will mark it as Kc. Okay, now behind Kc I'll mark it QC, and in front of Kc I'll mark it QC. Okay, so if QC is behind Kc, if QC is behind Kc, I have told you just now, every reversible reaction will try to attain the state called equilibrium. If QC is behind Kc, then that particular reaction will try to move forward until it reaches Kc. So if QC is less than Kc, the reaction will move forward until it reaches Kc. Now, if QC is greater than Kc, what happens? We know that QC has surpassed the equilibrium condition. QC has surpassed the equilibrium condition. So what does that reaction do? it will react backwards, it will shift its direction to backwards. That means the rate of backward direction increases. That means the reaction shift to backward direction until it reaches to the point called as equilibrium. So in this case, if QC greater than KC, the reaction shift to backward direction. This is how you are going to predict the direction of reaction if QC and KC is given. So it is easy. That is, if QC is less than KC, reaction shift from left to right. That means in the forward direction it moves. If QC is greater than KC, that is in this condition, the reaction shift to backward direction until it reaches to equilibrium. And if QC equal to KC, then there is no net reaction because the reaction has already reached the equilibrium point. So there is no net reaction. Hope this is clear for you. This is the easiest trick that you can ever use when you are asked with this particular type of questions. So just look into the question. The reaction quotient Q for the reaction, this is an Haber's process reaction, that is N2 gas plus 3H2 gas giving 2NH3 gas. We know that QC will be equal to concentration of NH3 square by concentration of N2 into concentration of H2 cube. This is QC. The reaction will proceed from right to left. So just draw that figure. We know that here it is QC, here it is QC, and the center point is KC. Now they are telling that the reaction proceed from right to left. So for reaction to proceed from right to left, then QC greater than KC. So the answer is option D is the right answer. That's all. How easy is this? Just see, 2003. This question is asked in 2003. Now, moving on to the next topic, the very interesting topic, that is the relation. This is reaction, it's not reaction, it's a relation. Relation between equilibrium constant K, reaction quotient Q, and Gibbs free energy G. Okay, क्या हो जाएगा रिएक्शन ही आपके पीछे? I didn't get you, Ashu. Which reaction you are talking about? About this reaction? This reaction will, it is telling that the reaction will proceed from right to left, means it will shift from right to left. So in order for the reaction to shift from right to left, what should be the condition? The condition should be QC greater than KC. Is that clear? Vashu, please let me know whether I am answering to your right question, or clarify your question, what you are asking. If you give a clarity on what question you are asking, so that I can clear your doubt. Okay, now for time being I am moving on, and this is at equilibrium. We know that the Gibbs energy change will be 0 and it will only have standard Gibbs energy change, and at equilibrium we know that Q is equal to Kc. So this reaction or this equation you study from electrochemistry. From electrochemistry you will learn this equation, that is delta G equal to delta G naught plus RT ln Q. Okay, or you can study it now. If you are not a repeater, you can study it now, because electrochemistry is a chapter that you deal in +2 or in your 12th standard. So at equilibrium we know that there is no delta G, the delta G will be 0, and because there is no net reaction at equilibrium, no net reaction happens, no transfer of electrons, we know that delta G will be 0, so the equilibrium, the reaction quotient will be equal to equilibrium constant. So delta G naught from this equation, you know that delta G is 0, so delta G 0 equal to delta G naught, that is standard Gibbs energy, plus RT ln Q. So delta G naught is equal to, you take this to LHS. If you take that to LHS, it becomes delta G naught equal to minus RT ln Q. So, sorry, instead of ln Q, I have to write it as ln Kc since the reaction is in equilibrium. So I can write ln Kc is equal to minus delta G naught by RT. So if I take Kc, if I want to find out Kc, then it will be equal to e raised to minus delta G naught by RT. Log will get converted to e raised to minus delta G naught by RT. So this is the equation that you have to study, and this is the relationship between Kc and delta G with temperature. Okay, if delta G is less than 0, we know that we have studied from thermodynamics. If delta G is less than 0, that means the reaction will be spontaneous. Spontaneous means the reaction takes place without any help of external agents. Okay, if delta G naught is greater than 0, then obviously the reaction is non-spontaneous. It is non-spontaneous. Okay, so here is a condition. If delta G is less than 0, then Kc will be greater than 1. That means if Kc is greater than 1, that means more product will be formed. And if Kc is less than 1, that means less product will be formed. That means the concentration of reactant will be greater than the concentration of products. Okay, so if Kc greater than 1 means product is predominant, and Kc less than 1 means reactant is predominant. Okay, this is what you have to understand. So so for delta G naught less than 0 means the reaction is spontaneous. That means more reactions will take place, more product will be formed, so the product will be predominant. If delta G greater than 0, that means the reaction is non-spontaneous, and non-spontaneous means less product will be formed, the reactant will be predominant. That's what you have to understand for this particular slide. Now the important topic, we are going into the Le Chatelier principle. Dear students, understand this concept clearly. Open your 2 ears and listen to this, what I am going to tell you. See, if a reaction reaches to equilibrium, then if you keep all the conditions as it is without making any change, the reaction proceeds in that particular condition. But if you change any of the condition or any of the state in the surroundings or present in the system, that is, if you change the temperature, the equilibrium will be disturbed. If you change the pressure, the equilibrium will be disturbed. If you change the concentration of reactants or products, the equilibrium will be disturbed. So once the reversible reaction reaches to the point or reaches to the state called equilibrium, it does not change, or it keeps on in that state of equilibrium unless until you make any changes in these variables like pressure, temperature, volume, concentration, number of moles, etc., etc. So Le Chatelier, very famous scientist, who taught us what happens or what will happen to an equilibrium reaction if you make or if you changes any of the variables. So Le Chatelier explains in most beautiful way that the reaction, the equilibrium will be disturbed, and the reaction will try to oppose the cause which disturbs the equilibrium. So how it is going to oppose the cause? By shifting the equilibrium reaction to forward or backward direction. So the reaction knows in which direction it has to proceed in order to oppose that cause and to reverse that condition and again bring about the equilibrium condition. So what I have told, if a reaction is present in equilibrium condition, if I am going to change the concentration, or if I am going to change the pressure, temperature, number of moles, volume, any variable that is present in the reactants or the products, if I make any change, the equilibrium will get disturbed and the equilibrium reaction will shift to that direction, either forward or backward, which will effectively restrict or react to the cause that has created a change in equilibrium, a shift in equilibrium. For example, if you understand a reaction is in equilibrium, now you are adding more reactants. What happens? Concentration changes, equilibrium get disturbed. Now the equilibrium will shift to that direction that will bring the concentration of reactants down. So can you tell me which direction the reaction will shift so that it will bring down the concentration of reactants? It is only one direction, that is the forward direction. If the reaction shift to forward direction, then obviously the concentration of the reactants will decrease, and because you have increased its concentration, so obviously the reaction will move in that direction to decrease the concentration of reactants and bring back that equilibrium condition. This is what the reactants do. If you increase the pressure on one side, the reaction will shift to the other side to decrease the pressure. If you increase the volume, the reaction will shift to that particular direction where you can decrease that particular volume. If you increase the temperature, the reaction shift to that particular direction where it can decrease the temperature. This is how the equilibrium acts when you change any particular variable like pressure, concentration, number of moles, volume, etc., etc. And this law or this principle is called as Le Chatelier principle. Hope this is clear for you. Right? Now, let's take a problem. Question. Which information can be obtained on the basis of Le Chatelier principle? See, there are four options. The very first option, you can see that equilibrium constant of chemical reaction. See, did the Le Chatelier principle told you anything regarding the equilibrium constant? No. So that is a wrong statement. No. A big no. Le Chatelier hasn't told us anything regarding equilibrium constant. Now the option B, dissociation constant of a weak acid. Never he have told about anything about acid or base. No dissociation constant. That also a wrong answer. C option, shift in equilibrium position on changing the value of a constant. Yes, that's what Le Chatelier told us. If you change any of the constant, or if you change any constant value, that means the temperature which was constant, the pressure which was constant, the concentration which was constant at equilibrium, if you change any of that constants, what happens? There is a shift in the equilibrium position, and that's what Le Chatelier told us. So the option C is the right answer. Let's look at the option D. Entropy change in a reaction. No way. Le Chatelier hasn't explained anything regarding the entropy change that happens in a reaction. Okay. Now moving on to the next one. We are going to discuss the Le Chatelier principle in detail by taking each constants of the variables, and we are going to change the each variable and we are going to identify what happens to the equilibrium reaction, or how the equilibrium reaction reacts to the change. Okay. So first one, if you are increasing the concentration of reactant, you know, according to the Le Chatelier principle, what the equilibrium reaction does, they try to decrease the concentration of reactant, because this is the cause. Increasing the reactant is the cause that you have made, which has disturbed the equilibrium. So now the equilibrium reaction tries to decrease that particular concentration. So in order to reduce the concentration of reactants, how the equilibrium should shift, whether it should have to shift to forward direction or shift to backward direction. What happens if the equilibrium shift to backward direction? Again the reactant concentration increases. So it wanted to decrease the reaction concentration of the reactants. So it have to shift the equilibrium to forward direction and reduce the concentration of reactants. So the equilibrium will shift to forward direction. Okay. Now considering the concentration of product. So similarly, I'm telling you, if I am decreasing the concentration of reactant, what happens? If I decrease the concentration of a reactant, then obviously the equilibrium will be disturbed. How come the equilibrium disturbed? Because I have decreased the concentration. I have made a change in the concentration which was constant. Now what the equilibrium have to do? It have to increase the concentration of reactant in order to reach to that equilibrium state again. So what they will do? They will shift the equilibrium to backward direction so that the concentration of the reactants can be increased to that level where they can attain or re-establish that equilibrium. So if concentration of reactant is reduced, the equilibrium will shift to backward direction. Now what about the product? If you increase the concentration of product, we know that the equilibrium get disturbed. What happens? What happens? Bolo, what happens? The equilibrium will get disturbed. Now the reaction will shift to the backward direction in order to decrease the concentration of the product. So it will move backward. Now similarly, if I decrease the concentration of product, what happens? Bhaiya bolo, what happens? The reaction should shift to forward direction in order to increase the concentration of product. So it will shift to forward direction. Now let's think about the favorable condition. Favorable condition. Dear students, what do you mean by favorable condition? Favorable condition means among these four conditions, which condition is most favorable for the production of products? Among these four conditions, which is the most favorable condition for the production of products? Which is the most? I can say I have to consider that reactions which are shift to forward reaction. So this is the first case and the second case. These two reactions will give us more products, right? So these two conditions, from these two conditions, which is the most favorable one? Here you have to increase the reactant. Here what you have to do, in the second case what you are going to do, you are just taking away the product. You are decreasing the concentration. So which is economical? First one or second one, which is economical? First one means you have to add more and more reactant in order to bring the reaction forward. In the second one, you have to retrieve the product so that the reaction will shift to forward direction and give you more product. So the second one is more economical. That means the most favorable condition is decreasing the concentration of product. So this is the most favorable condition. So an example is given here. H2 gas plus I2 gas giving 2HI gas. If H2 is added, that means you are increasing the concentration of H2. The reaction will shift to forward direction in order to decrease the concentration of H2. Hope that is clear for you. Yes. Now let's discuss about how this question we are going to solve. If the concentration of OH minus ions in the reaction, so let's is decreased, the concentration of OH minus in the reaction is decreased by 1/4 times, then equilibrium concentration of Fe3 plus will increase by how much? Very, very interesting question, and this question has been asked in 2008. So first of all, let's write the Kc equation for this equilibrium, that is Fe3 plus and OH minus raised to 3. So now you are decreasing the concentration to 1 by 4 times the concentration of OH minus. So that means I am going to take the concentration of Fe3 plus as X and concentration of OH minus as Y. Okay. So here Kc will be equal to X into Y cube. Right. Now what I am doing, I am decreasing the concentration of OH minus to Y by 4. So now I am writing it as K equal to X into Y by 4 raised to 3. Okay, that is Kc dash. That means XY cube by 64. Okay, 4 into 3, 4 raised to 3, that is 4 into 4 into 4, that is 64. So the equilibrium concentration of Fe3 plus will increase by how much? That's the question. See, you can see here, if you change the equilibrium concentration of Y, then this can be X dash. Okay. So now you are going to equate 1 and 2. This is 1 and this is 2. So XY cube is equal to X dash Y cube by 64. So you can cancel this Y cube and Y cube. So X dash will be equal to 64 into X. That means there will be an increase in concentration of Fe3 plus by 64 times. So option D is the right answer. Moving on to the next one, effect of pressure change. Dear students, here you have to understand that a very simple concept. If you are increasing the pressure, pressure is directly related to the number of moles of gas. Okay, pressure is directly related to the number of moles of gas. We know that PV equal to nRT. So if you are increasing the pressure, what equilibrium does? It requires to decrease the pressure. It tries to decrease the pressure. How it decreases the pressure? By shifting the reaction where the number of moles of gas is less. See, if the number of moles of gas is less in the product direction, then the equilibrium will shift to the forward direction. If the number of moles of gas is less in the reactant side, then the reaction will shift to the reactant side. So if you are increasing the pressure, then equilibrium tries to decrease the pressure by shifting the direction of the reaction where the number of moles of gas is less. So this is how the system decreases the pressure. Hope that is clear for you. Okay. Now let's take this example and understand this point. The effect of pressure is inversely proportional to the effect of volume. If I say what happens when pressure is increased, the same answer is valid for volume decreased case. So by understanding the pressure condition at a time, you are understanding what happens with the volume also. So pressure increase and volume decrease conditions are same. Pressure decrease and volume increase conditions are same. So understand, I am not going to explain what happens with volume increase or volume decrease. In fact, I will explain what happens with pressure increase and pressure decrease. From that you have to understand what happens with volume decrease and volume increase. Right? Now, here in this question, this is not cobalt, instead it is carbon monoxide. If I increase the pressure, you can see that in the reactant side there are 4 moles of gas. Here 3 hydrogen gas, here 1 carbon monoxide gas, so 4 moles of gas. Here only 2 moles of gas. So that means the number of moles of gas is less in the product side. So if you are increasing the pressure, the equilibrium shift to that direction where the number of moles is less. So equilibrium will shift to forward direction, because in the product side the number of moles of gas is less. In the reactant side number of moles of gas is more, and product side number of moles of gas is less. Now considering the second case, you can see that carbon is in solid, and here the reactant, gaseous reactant, here it is 1 mole, here it is 2 mole. So if I am increasing the pressure, the system has to decrease the pressure. How they will decrease? By shifting the reaction to that direction where the moles of gas is less. So the moles of gas is less in where? Less in the reactant side. So the reaction will shift to backward direction. Hope this is clear for you. So pressure increase and volume decrease, same case. Pressure increase and volume decrease is same case. So you can write the same answer for both. If they are asked in the case of volume, they just think in the case of pressure and write the answer. If they are asking about volume decrease case, think about pressure increase case and write the answer. If they are asking you about volume increase case, think about pressure decrease case and write the answer. Okay. Now effect of inert gas addition. So at constant volume, if you are adding inert gas to the system, then there is no effect on equilibrium. Okay. But at constant pressure, if you are adding equilibrium, the equilibrium shift towards larger number of moles. So at constant pressure, if you are adding inert gas, the equilibrium shift to that side where number of moles of gas is more. So if delta N naught is greater than 0, the number of moles of reactant is greater, so reaction moves forward. Okay. If delta N is less than 0, then the number of moles of here it is opposite, number of moles of product should be greater than number of moles of reactant, so reaction moves forward. And for delta N less than 0, that means number of moles of reactant is greater than product, so reaction moves backward. And if delta N is equal to 0, there is no effect on the equilibrium. Hope this is clear for you. And you know that what is delta N and all. We have discussed that in the previous lecture. If you do not know, please go and watch that so that you will get a correct, clear picture on what happens with delta N. Now, what about the endothermic and exothermic? See, if you are increasing the temperature, then you have to check what kind of reaction it is with respect to the heat exchange, whether they are endothermic. Endothermic reactions require temperature. So if you are increasing the temperature, you are favoring the forward reaction. That means the equilibrium shift to forward direction. For endothermic reaction, if you increase the temperature, reaction shift to forward direction. For endothermic reaction, if you decrease the temperature, the reaction shift to backward direction. So once you understand what happens with endothermic, just the reverse will happen with exothermic. So for exothermic reaction, if you increase the temperature, reaction shift backwards, just opposite of endothermic. And if you decrease the temperature, reaction shifts forward. Okay. And you can learn this equation, this formula, Clapeyron equation, and this is one of the important equations that you have to understand and learn. Okay, this is giving you a clear relationship between the equilibrium constant and enthalpy change. Okay, right. So we have discussed this already. For endothermic, if you increase the temperature, reaction shift to forward direction. For exothermic, if you increase the temperature, reaction shift to backward direction. Now this is just an example. It has nothing to do with any question. Let's because we have lack of time, I'm going to the question. For the reversible reaction, N2 plus 3H2 giving 2NH3 plus heat. If heat is given here, that means the reaction is exothermic. This is a question that is asked in 2014. Okay. Now the equilibrium shifts in forward direction. We have to find out in which all condition the equilibrium shift in forward direction. So by increasing the concentration of NH3, no way. If you are increasing the concentration of NH3, reaction shift to backward. So in this case, reaction shift to backward. By decreasing the pressure, okay, let's check. If you are decreasing the pressure, the reaction will shift to that direction where number of moles is more. So number of moles in reactant side is 4 mole. Here 1 N2 gas, 3 H2 gas, so 4 mole. Here 2 NH3 gas. So the number of moles is greater on the reactant side. So in this case also reaction shift to backward. Since you are decreasing the pressure, the reaction tries to increase the pressure. So for increasing the pressure, it have to shift to that direction where the number of moles is more. By decreasing the concentration of N2 and H2. If you are decreasing the concentration of N2 and H2, then the reaction again shift to backward, so that the equilibrium, so that more reactants will be formed. By increasing the pressure, okay, if you are increasing the pressure, then equilibrium will try to decrease the pressure by shifting the reaction to that direction where the number of moles of gas is less. So the number of moles of gas is less in the forward direction, so obviously it will shift the reaction to forward direction. And the second sentence, that is decreasing temperature, we know that for exothermic reaction, if you decrease the temperature, reaction shift to forward direction. So the answer is D. Okay students, hope that is clear for you. Move on to the next. The value of delta H. The value of delta H for the reaction. Here you have been given a reaction X2 gas plus 4Y2 gas giving 2XY4 gas is less than 0. So delta H less than 0 means what? The reaction is exothermic. The reaction is exothermic. That is what meant by delta H less than 0. Okay. Now formation of XY4 will be favored. So XY4 is a product, and we have to give that condition which favors the formation of XY4. So let's check case by case. High pressure, if pressure is increased, the reaction will shift to that direction where number of moles is less. So here you can see the number of moles is 5 here. In the product side, the number of moles is just 2. That means the reaction will shift to that direction where the number of moles is less. So this condition, high pressure condition, favors forward direction. Now low temperature. Exactly, this reaction is exothermic. Since the reaction is exothermic, if you decrease the temperature, reaction will shift to forward direction. So this is the very good answer. Very right answer. High pressure and low temperature. Now the next one, BaO2 solid giving BaO solid plus O2 gas, delta H positive. Delta H positive means the reaction is endothermic. So in equilibrium condition, pressure of O2 depends on, let's check. Pressure of O2, increased mass of BaO2. See, if you increase the mass of BaO2, nothing will take place because BaO2 is solid. So its concentration is constant. If you keep on increasing the mass of BaO2, nothing is going to happen. Right? Increased mass of BaO. If you increase the mass of BaO also, is nothing going to happen because again they are solid, their concentration is constant. So the constant concentration cannot increase or decrease the concentration of O2. Right? Now increase in temperature. So see here, it is endothermic. So if you are increasing the temperature, it favors forward direction. That means more and more O2 will be formed. So this is the answer, C. So effect of catalyst, this is the last topic which we are going to discuss today. So one thing you have to understand, see, catalyst is not going to change the state of equilibrium. It is not going to change the value of equilibrium constant. What catalyst does is that it lowers the activation energy and it helps the reaction to reach equilibrium at a faster rate. So catalyst is not going to participate in the reaction. Catalyst is not going to change the state of equilibrium. Catalyst is not going to change the value of equilibrium constant. But what catalyst does is that it provides a surface area for the reactant molecules to collide. So the frequency of collision increases, the rate of reactions of forward and backward increases. So the equilibrium point will be achieved at a faster pace. So catalyst helps us to reach the equilibrium point at a faster rate. That's what the catalyst does. Okay, so that's what you have to understand with respect to catalyst. So which one of the following statement is not correct? This is the last slide which we are going to discuss today. So which one of the following statement is not correct? Coenzymes increase the catalytic activity of enzyme. See students, I want to give you an example here. N2 plus 3H2 giving 2NH3. This is a well-known example of Haber's process. Here we use the catalyst as iron, and we use one more thing that is called as molybdenum, and molybdenum is a promoter, and this promoter, what does this promoter do? This promoter increases the efficiency of iron. That is, iron is catalyst here, so it increases the efficiency of iron. So coenzymes are those act like the promoter. So coenzymes are like promoter. What it does, it increases the catalytic activity of enzyme. So option A is right one. Catalyst does not initiate and take part in reaction. So this is also a right statement. The value of equilibrium constant is changed in the presence of catalyst in the reaction at equilibrium. The very wrong statement, because I have told you the value of equilibrium constant is never changed by a catalyst, and it cannot change. If you put a catalyst in an equilibrium reaction, a reaction which reached at equilibrium, it is not going to change that equilibrium state. Okay, enzymes catalyzes mainly biochemical reaction. We know that enzymes are chemical catalysts or biological catalysts which is present in our body. Because their targets are biomolecules, they are called as enzymes. So enzymes are nothing but catalysts which act in the biochemical reactions. So this is also a true statement. So this is what students we had discussed today. So hope the Le-Chatelier principle and the corresponding questions are clear to you. The concept is clear to you, and we will be meeting inshallah in the next lecture. So I wanted you all to listen to this lecture and do as much problems as you can from the Le-Chatelier principle. And that's all for today, dear students, and take care and bye bye and good night. Have a nice day, have a nice dinner, and good night. Thank you.